This is a trapezium rule question. We can see the bit in yellow here has just been taken straight out of the formula book, which is our formula for the trapezium rule. So we're being given, so this is for 5a, we've been given that we're looking to find an approximation for the integral between these two. So up to now, we don't know how to integrate this function. Okay, in core 3 you'll learn how to do it, but up to now we don't know how to. So we're going to have to use the trapezium rule to approximate this. So at no point are we going to try and integrate this because we don't know how, we haven't got any methods to do that. So instead what we will do is we will use the trapezium rule for 3 strips, 4 ordinates to find the approximate value. So the first stage with any trapezium rule question is to write out what your height of your trapezia are going to be. So in this case it's b minus a, 11 minus 2, divided by how many trapeziums? 3 trapeziums, n is equal to 3. Okay, so we've got 9 over 3, so the height of my trapezia is 3. So what I'm going to do is I'm going to set up my table up here. I'm going to have my x values, my ordinates, and I'm going to have 4 of them, x0, x1, x2 and x3. So my first ordinate is the lower boundary of my region is 2. I then use the height 3 to find the next values. So the next height is 5, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. Now if this last number doesn't correlate with the top number in your region, you've done something wrong. So at that point you know you need to go back and change something. So if that number is not an 11, you know you've got it wrong. We then need to find our corresponding y values. So the y values that work with this function. Now, this is now an exercise in substitution into the calculator. So I'm going to be doing the square root of x squared, so whatever x is gets squared, and then I add 9 to it. Okay, so my first x value, my first ordinate is 2, so I put 2 in there, and the y value is root 13. Now there's no reason, if you're left with a really nice surd like that is, don't try and work out what it is as a decimal and do any rounding because you're likely to make mistakes. This way I'm not making any mistakes, root 34. So leaving it as a surd is a much more exact value than anything else that we could think of doing. So we will leave it as a surd as I'm substituting in my different values. So that one was, I've forgotten what that one was now, 73. And then my final one, popping 11 in there, is root 140. Sorry, 130. Okay, so they're my y values. Now I'm using this formula here. Now, I don't know about you, but I like to try to remember what this formula is actually doing. It's doing a half times 3, and all of that is the first and the last one added together just the once, plus twice the middles. So instead of worrying about whether I've labelled things right, I've just remembered what I've done. Now, it's really important to write this line, because writing this line is what gets you 3 out of the 4 marks. If you don't write down this line and you just sub these numbers into your calculator, if you make a mistake, you will lose at least 1 mark, probably 2. So now I'm going to use my calculator. Now notice where I've put brackets, because it's really, really important that you do exactly the same thing. What a lot of students do is they forget these first set of brackets, and what this means is that you're just doing a half times 3 of the first 2 terms, and then you're adding on the next bit. That's not what trapezium rule says. Trapezium rule says half times 3 of everything. So you need to make sure when you're putting it into your calculator, you are doing a half times 3 of everything. So I'm just going to put these numbers in as they are. So you'll notice I've got 2 brackets here. The first bracket is the big bracket that I've drawn on outside. The second bracket is the one for the first 2 terms. And then plus twice, and then I've got my next few terms. So root 34 plus root 73. Close off that bracket, after the square root. So that's just the first bracket I've closed, and then close the second bracket. press return, and I've got my solution. Now, the question, we'll scroll back up to it in a second, it does ask for some rounding. I'm going to write it to 3 decimal places to start with, so 65.636. So that's to 3 decimal places. And now if we just look up to the question, give your answer to 1 decimal place. Failure to do that, you will lose a mark. So have a look at the question, have a look at the solution, sorry, it's 65.6 to 1 decimal place. And that is how we use the trapezium rule. So it is 4 marks, there's a lot of work to do, but it is following exactly the same process every single time. So it should be something that we can do. I'm going to remove all this workings now from this video, so pause it if you want to have a look at those, and then I'll have a look at the transformations for part B. Okay, we're on to part B then. So we've just done the trapezium rule and we're now doing 5B, which is a couple of transformations questions. So y equals the square root of x squared plus 9, and we're looking to transform that firstly into 5 plus the square root of x squared plus 9, and that's y equals again. So what's happened? We've had this additional 5 that's been added on outside the function of x. So this is the function of x. It's not happening in there, it's not happening in the x squared bit, it's happening outside the function. So because it's happening outside the function, we can deduce that it's something in the y direction. It's being added, so we know it's a translation, and we're saying it's in the y direction, so it's as we expect it to be, so it's 5 additional. Okay, now it must be written like that to get the marks. You must use vectors to describe your transformations, and you must use the correct keyword. Moved, shifted, things like that, they are really sloppy mathematically. You want to use the right mathematical word and impress your examiner. What is it that's actually going on here? And as I say, that's then they're going to sort of know that you know what you're doing. Okay, for B part 2 then, this one you'd be forgiven for thinking that it was a stretch in the y direction. But what's really important to notice is that this number here is now a 1, it's no longer a 9. So we have gone from y equals x squared plus 9, all this in the square root of all that, sorry, onto y equals 3 lots of x squared plus 1. So somehow we have managed to sort of go across here, and this whole thing has been changed, but this 1 is the thing that's really standing out to us as, well, that's been divided by 9 somehow. So we're going to have a look and think about how we can rewrite this to include that 9. Okay, and the way we're going to do that is think about this as surds. So write 3 as root 9. Okay, so it's root 9 times by the root of x squared plus 1. Now we know with surds that we can just multiply them together and make a single surd. So this is the same as 9 lots of x squared plus 1, all inside the square root. So it's 9 lots of x squared plus 9, all inside the square root. Now here, if you are having the 9, x is getting squared. What are you doing to the x? You're doing 9 squared, which is 81. We don't want that. We want 3 squared, which gives us the 9. So this is equivalent to saying 3x all squared plus the 9 square root. Okay, now in spotting this and being able to write it as this, what we can then see really, really clearly is what's happened. How have we got from this one to this one? So it's almost sort of remembering that we're looking at what's happening to the x. So it is a translation. No, it's not. Sorry, it's not. It's a stretch because it's a multiplication. So it's a stretch. It is in the x direction because it's happening inside the function. It's happening to the x value. And then what is the scale factor? Well, it's the opposite of what we expect. So it's a third So the scale factor is 1/3. Now, you might be thinking, hang on a minute, I didn't really get what happened here. Imagine going back the other way. Okay, it's got to be something inside. So if you expand this, we get 9x squared, which allows us to work our way through. Any other number in front of the x here, it wouldn't allow us to do it. If we considered it at this point and stopped here, this is not happening inside the x. You're inside, but you're not inside enough. It's got to happen just to the x value. So 9x is fine, but you've got to make sure you're squaring it, which, as I've previously said, would give us 81. So that doesn't allow it to work. You've got to think, does it work going backwards? Does this work going up? And having the 3x there definitely does. If you don't have 3x, if you have it here, you're not quite in the house. You're on the porch. You're at the front of the house, but you're not there yet. It's got to happen inside the function, so it's got to be 3x all squared. Tricky question, but definitely worth getting your head around exactly how that's worked.